So we've seen this formula before. This formula allows us to work out the angle that exists between any two given vectors. So suppose you've been given this vector and this vector, we would somehow work out the dot product, and then from the dot product we would eventually get to the angle. So we can work out the angle. Suppose we have a vector here and a vector here. We would somehow work out the dot product, and then from the dot product we would somehow get to the angle. So given any two vectors, we can work out the angle. So what we've got so far is given two vectors, we would input two vectors, and then it will spit out an angle for us. That would also mean that we have looking at this formula, it will also mean that we have a way of detecting if one vector is perpendicular to another vector. So now we can work backwards. Put this into here, and then work backwards to find out the condition needed in order for the two vectors to be perpendicular to each other. So let me start again. Given two vectors, we can work out the angle. Given this vector, we can work out the angle. So now we want to know the conditions needed in order for the angle to be at 90 degrees, in order for the two vectors to be perpendicular to each other. So to do that, we would put this into this angle here. So that will then take us to here. So we are trying to work out the conditions needed for two vectors to be perpendicular to each other, to be at 90 degrees. So looking at remember cos pi over 2. So cos looks like this. Pi is here. Pi over 2 is 0. So this thing here is 0. So looking at this now, if we can somehow get this to be equal to 0, then the angle will be at 90 degrees. If looking at this, we are trying to find out what conditions are needed in order for two vectors to be at 90 degrees with each other. Now, put this into here. If we can somehow make this to be 0, then that means the angle will be at 90 degrees. So going back to here, hang on. So this thing here equals 0. If we can somehow get this to be 0, then the angle must be pi over 2. So looking at this, here you've got a magnitude. If you have two vectors, then the magnitude, the two magnitudes are not going to be 0. There must be an associated length to the vector. It can't. In our case, it can't be 0 unless you have a dot, but that doesn't really make sense. So two vectors must have some sort of magnitude associated with it. So this thing here cannot be 0. So we're trying to make this to be 0. So concentrate on making this to be 0. So the conditions needed would be if the dot product of the two vectors is 0, then that means the angle must be 90 degrees. So going back to here, if this thing here is 0, then it will mean that the angle must be 90 degrees. So let's put it to the test. So suppose you have a vector here, 2 across, 1 up, 2 across, 1 up, and then you have this vector here where it's -2 and then 4 up. I hope you can accept that this is going to be 90 degrees, pi over 2. So now let's detect if the two are perpendicular to each other. So compute this value here. Compute the dot product. So the dot product is this times this. That will give you this plus this times this, and then add the two together. It gives you 0. So this thing here is 0. Therefore, we can conclude that the two vectors are at 90 degrees with each other. So this is pi over 2. So let's extend this to 3D. So in 3D, I'm going to create a vector where the first one will be somewhere along this plane. So let's say 2. It can be anything. 2 in the x direction, 3 across, 1, 2, 3. So our vector is along that plane. it would be right here. So this is our vector here. It lies on this plane. Okay, so another vector would be, it doesn't matter how high up, I chose it to be 10. So 0 in the x direction, so 0 in the x direction, 0 in the y direction, and then 10 up, 10 up. Let's say this is 10 here. So now let's compute the, well, if we want, I hope you can accept that this is going to be 90 degrees, because this vector here lies on the plane and this one's straight up. So it must be 90 degrees. I hope you can accept that. So now let's put it to the test. To detect if two vectors are at 90 degrees with each other, we would compute the dot product. If the dot product equals 0, then we know the two vectors are perpendicular to each other. So the dot product, this times this would be 0, this times this would be 0, this times this would be 0, add the 3 together, it will be 0. So therefore the two vectors are at 90 degrees with each other. Okay, so given this formula, if the dot product equals 0, then the two vectors are perpendicular, orthogonal, or normal. All these mean the same thing. Okay, so remember it. Well, normal in physics. Remember, if a car's going over a hill, you've got your tangent and your normal force. So normal is like 90 degrees to the tangent. And remember when we first started out with calculus, this here's your tangent, this here's your normal. So and so on. All these mean the same thing.